Oh. No! Hey, Vicky. Who else is in here? There's 4 people, huh? Say hello, please. I'm very lonely. Oh, do you guys see all my company? Wow. See my friends over there? See my friends over there? You see I'm very lonely? Please say hi. Hey, Cassie. Hey, Sumaya. John, thank you. Thank you so much. It's not easy being alone, you know. Okay, so Joseph, hey, Tina, where were you yesterday? Alexi, hey, Aaron, hello. Labiba, good morning. Esther, hello. Rika, hello. Aaron, yes. I will, for those of you interested in how recommendations are going to go, I will be, hey Alton, I'll be talking about that in more detail Friday. Ooh, open office hours, all right? Tina, it's fine. I know we all have a lot of stuff going on right now, and it's not going to be possible to do all the work all the time, right? But it's just the main important thing is to not let yourself get too behind, because it can get, I know this firsthand, it can get really overwhelming to try and catch up on stuff if you're way behind, right? So just don't let that happen, okay? That means if you're 3 weeks behind, that might mean throwing away all the stuff from 3 weeks ago and just focusing on the past 2 weeks. It's fine. Just do what you can, all right? I'm not going to judge you, all right? I'll only do that when I write your recommendations. Cool. So today we are going to review the answers to the homework, which 27 of you have turned in out of 68. Don't know what that's about, okay? Hold on, I'm just getting a little sad. It's fine. Hey, Rosie. Hi, Elon. Okay. So, well, I just skipped. Okay. The difference between a mirror and a piece of paper is that they light undergoes 2 different types of reflection. There is specular reflection. That's reflection that looks like this. Okay? It maintains the order of the light rays that hit it, right? And then there's a type of reflection called diffuse reflection, okay? And diffuse reflection scatters light. So another way of talking about it is scattering, okay? So I'll have 3 rays that come here, but this one might go this way. This one might even go phew, this way, and this one might even go as extreme to go like phew, this way, right? So basically the light scatters and goes in random directions. This is diffuse reflection, right? I want to answer the first question, like why. So obviously this is the mirror and this is the paper, right? But why does one appear white and why does the mirror act like a mirror, okay? Well, I'll tell you why, all right? So in terms of the mirror, okay, if I have an image of something, right, like, so basically, if I have like a person, and here's a mirror, and then well, here's light from their head, their hand, and their foot, and if I observe them, right, I'll essentially get light from their head, their arm, and their foot in that order, right? And this is what I perceive, okay? However, if this is a mirror, this is paper. Why does the paper appear white? Because guess what? If I'm here and I'm receiving 3 light rays here, okay? Those light rays could have come from anywhere. They could have come from this person. They could have come from a red object, right? So this could be like a red wave, like maybe light from an apple hit it, right? And then guess what? Maybe also I have like a green, my house plant, right? Hey baby, say hi. Say hello. Hi. Hello students. All right. Hello students. Okay, so maybe light from my plant somewhere, right, hits this point, also gets reflected there. Why is it allowed to go in this direction and come out that direction instead of not going to this direction and this one not? Because it scatters, right? So basically this ray of light here that hits my eye comes from a variety of sources due to the scattering, and when they combine, it looks white, right? Because white is the combination of all colors. Whereas with the mirror, the only thing hitting my eye from this direction is a ray of light coming from this direction because it's smooth, right? Like light coming from this direction, hitting this point, will never go there because that's a form of scattering. This light will go in this direction. It follows the law of reflection, right? What's the law of reflection? That this angle equals that angle, right? That's the law of reflection. That happens everywhere, right? So in the scattering, right, it looks white because basically this ray of light is a combination of a bunch of reflected ones from every direction conceivable because it's scattered. Now I want to get into the mechanism behind scattering them. Okay? Well, why do things scatter in the first place? Great question, okay? Because I thought no matter your boundary, if you're rough or if you're smooth, that you should follow the law of reflection. And you're right. But guess what? A rough surface, microscopically, could look like this. And if I send 3 rays, okay, This one will follow the law of reflection based on this normal line. This one will follow the law of reflection based on this normal line. This one will follow the law of reflection based on this normal line, okay? So how will they bounce? This way, and then this one goes this way, right? So they are following the law of reflection. It's just that the surface they're reflecting off of is tilted because it's rough, okay? So this is how diffuse reflection works. It actually works just like specular reflection, right? Except there are just really multiple types of smooth, flat surfaces, right? Where specular reflection is all flat. So they'll all do that, right? Where diffuse will scatter. If you're in a blue room and everything in the room is blue, the paper will look blue. Yes. Yes. Here, I'll give you an example. Here I have a lamp. I'm going to turn it on. And I have this grape juice bottle here, okay? And when I put it over the lamp, it becomes a green lamp. So only green light is escaping from my lamp now. And if I hold a sheet of paper under this green lamp, the paper looks green because only green light hits it, so only green light reflects off of it, right? A white object only looks white if it reflects every color, right? Color is not an intrinsic thing. You perceive an object to be a certain color because that frequency of light is hitting your eyeball. Why is that frequency of light hitting your eyeball? Because that frequency of light reflected off of the surface, right? So if green light hits it and green light's reflected and green light hits my eye, it's gonna look green to me, right? But if a bunch of colors hit it and a bunch of colors are reflected, it'll appear white. Is it possible to smooth paper enough to get specular reflection? It's diffuse reflection and specular reflection. Specular diffusion is not a thing. No. Only certain materials can get polished, like metal, right? What's an example of a metal that has diffuse reflection? The rough side of aluminum foil. I can't see my reflection here, right? But the smooth side, you kind of can, all right? Like you can see this image of my hand, right? But you can't do it here. It doesn't really depend on the material. It depends on how you polish it. And almost every metal can get polished to a degree smooth enough to allow for specular reflection. Like a mirror. That's all a mirror is. Traditional mirrors are silver plated, and they're quite expensive. Modern ones are made with aluminum backed on glass. Ah! Oh my gosh, Rosie, can you email me that question? Okay? Because we're going to answer that next week. And it's going to be so cool, all right? That's the end of the lesson. It's just building on what we learned yesterday, specular versus diffuse reflection. Tomorrow, we're going to talk about the Doppler effect in light, okay? All right, so get pumped about that, all right? Have a great day, everybody. Bye-bye.